and I'll write it up here as well. We are going to look at, also remember that the number under the square root can never be what?
Negative.
That's where we're, as of right now, but we know when we get big, it can be negative. So we're going to look at always. Or never, sometimes never. Oh. Thank you, Sabrina.
I didn't say
Alright, always, sometimes, or never true. So what I want you to do is take a second. It's kind of the same thing we looked at yesterday. I want you to look and see on, you have a scratch sheet of paper? Did I take all your paper?
You're supposed to give it to
That's all you said. You don't want my paper.
Don't.
It's just easier to
I don't even know.
Paper? You're so sweet. You want my paper?
Oh, they gave a lot of paper.
I know.
Oh, give me some. I only have 2 sheets.
Alright, so on your new borrowed paper, y'all have paper, Coco? Are you gonna give me a picture? Alright, so also remember that you can never have a negative number, so I want you to tell me if this statement is always, sometimes, or never true. Square root of x minus 5 is equal to the square root of x minus the square root of 5. On your portrait, you gotta tell me, you gotta prove it to me. Yes, so in there. You're right on one, but is there an for a number that is hidden? That will make it true. Never. So can we use a concept that we used on the bell work to solve this? What?
Can you just,
What's some ways that you could solve it? Because we got some people having brain farts.
You could,
Yes, it is there.
it's coming and it's going all at the same time.
You got like the lights this morning, huh?
Yes.
Help that out. Can someone help that out? What can you do to both sides?
you can.
Oh, square them.
Square, and what else could you do? Not to both sides, but just in general to help you out.
Plug in a number.
Plug in a number. If you just plug in one number, would that suffice?
Yeah.
That's enough?
Yeah.
So if that one number you plug in doesn't work, you're done with it. You're not going to try another one.
No, you can't try another one, because I mean, obviously if it doesn't work, don't do it.
You have to do more or less.
Okay. Try some numbers. Try one and see if you say yes. Try it. Yeah. No push. Okay. Nope, hold in.
This is what you're getting, right? One is -4, incorrect, but 6 minus 5.
Yeah, but like since they're equal to each other, if you plug in 6 here, you gotta plug in on that side as well.
It's still the same. Wait, no. Because the square root of 6 would be
Something.
some weird.
So you put those in your calculator too, and see square root of 6 minus square root of 5 is the same concept. You square both sides. You gotta square the whole thing. Like let's. Alright, so look, if I have, focus for a second. If I have, what is it, the x minus square root of 5, and I want to square that,
It just takes the
how many of those do you have?
one.
I have 1 inside, but it tells me I have what? 2. What do we have to do to solve it? Say it again.
I don't think I did this right.
What do you have to do?
Oh, you have to pull.
Well, because why? Is this the same thing?
Yes.
Can you do that?
Oh, no. That's not something.
Uh-uh. No, it's not. Because it's telling you have 2 of them, because you're missing the minus sign.
I didn't know it was. How'd you get that? So, hold on. So, this is the number that we weren't putting.
So let me show you something. You rounded it.
You know what I'm saying?
Like, you rounded it, so you gotta keep it exactly like that.
Okay, so, hold on. When you do it, you're gonna do, what, in the square, or not, the square root of 5, which is that number. And then plus 5, which is that number.
So you're gonna put 1 then.
First, I want to make sure that it works with this one. I'm adding 5. This is the number.
So you're adding 5 right here?
Yeah, but the reason I'm adding 5 is because I want to.
So you're adding 5 to this.
No.
You're putting 5 there. You're adding 5 to the bottom. You're trying to subtract, add 5 to those sides.
On this side. Like, I don't know.
I get what you're saying.
I don't know how I see it.
I get what you're saying. You're trying,
Can I get the answer? I can ask it.
yeah, you're trying to move this one over.
Yeah.
Okay.
Okay.
Alright, so can someone tell me a value for x that's incorrect, that does not work?
1, 5, 6.
1, 6. Anyone else try another number?
I think 2 different numbers.
What did you try?
12 and 3.
12 and 3. So those do not work, right? Did anyone find a number that did work?
5.
5. Why does 5 work?
Because they cancel out.
They both cancel out. So if I say 5 minus 5 is 0, and then square root of 5 minus square root of 5 is also 0. Okay, so are you sure that that's the only one that works?
I'm working on one.
If they're the same number, they
If they're the same number, they always cancel out. So what do y'all think it would be if we changed this 5 to 6?
Then 6 would work for X because it's still cancel out.
6 would work. So we could keep going, right? We could change it. Okay. So is this statement always true, sometimes true, never true? Sometimes? Always? You think it's always true?
Well, it can't be always because if you use those numbers and they didn't work,
Right.
then it's gotta be sometimes because you can still use the same number. It would work.
So can someone say that differently? How else will we know sometimes? When you say sometimes, okay. When would it never work?
If there is a number that other than 5.
A number other than 5. For this one, it would never work. Alright, if you will, get in your train. So I know we have some people absent, so find your partner, you can go ahead and turn your desk. So make sure that we all have partners. If you have 3 in a group, that works out to 10, you have partners. Alright, so your purple sheet of paper needs to be broken into 3 parts. There's an example. It's alright. You're okay. So, say again. Always true, sometimes true, never true. So pick up.
Oh my God.
Not yet. Don't start cutting. I'm passing out the directions. I'm also going to go over the directions. The directions are also on the projector so you can see them. Wait. Just in case you can't see, back to the board. Alright, so once you break your sheet of purple paper into 3 separate parts, I want you to look at the cards that you have. They go from A to F. We'll actually do G and H probably tomorrow as an introductory to imaginary numbers tomorrow. Alright, so your directions, you have your directions, but let's take a second. We've kind of got them understood. First, what's the first thing you do?
Cut it out, and then try to solve it.
Okay, of course, right? Because what fun would that be if we didn't solve it? So second, what do? Second is for what?
If you think the equation is sometimes true, find the values of x. Or this equation is true and values of x, which is not true, find it. And then explain the
Right,
equation.
you know what to do? Alright, tell me what to do for number 3.
Your partner then decides if the card is in the correct place. If you think it is correctly placed, explain why. If it is not correctly placed, move the card to the position and explain the reason.
Alright, so do you just get to put them there? No, I like this when it goes here. I like this when it goes there. Do you get to just do that? What do you actually have to do? Solve it? Solve and explain why you think that is there.
Do it here first or?
Why? Okay, let's
Whatever we do.
Well, now you could,
When I have like the square root.
you could square it. That would keep it square both sides, and you can put it on, pass it on both sides on this one. You can square and square. These could go, let's plug in a number. Let's try like that. Calculator. Like a cheat, right? In case you don't realize. So, like, what would y'all like to do? Great. So, help around. You did it right. And then, so it's 3. So let's try it on this side. Alright, so if you are finished, if you're finished, we're going to do, you know what we did with equations and we go out in the hall and do an art gallery? Will you go ahead and hang yours up in the hall, not fall?